Hi everyone, it's Mrs. Rye here. I'm going to be talking about week 9, taking you through Monday night's homework. I hope you find this helpful. Monday, let's start with number 1. Alright, number 1. Solve the equation. This is a review of multi-step equations. I'm looking at my variables, and I need to get my variables together. So I see the 3x over here, and I see the negative x on the right-hand side. We need to get those together, but they're on opposite sides of the equal sign, which means we have to go opposite. We need to do our inverse operation, so add x to both sides. When we do that, the x's cancel on the right. On the left, 3x plus x is 4x. Bring down the plus 7. Bring down the negative 1. A couple more steps. So on the left-hand side, we see that this plus 7 is here, so we want to subtract using the subtraction property of equality. Cancel the 7's on the left. Bring down the 4x. Negative 1 minus 7, or combining negative 1 and a negative 7, negative 8. Then we divide both sides by 4. Cancel the 4's on the left. X is equal to negative 2. So for number 2 is the table of function y or y not. If you remember when we were going over functions, you had to make sure that if you have your x values, negative 3, negative 5, 19, 0, that when you compare the outputs, each input goes to exactly one output. So even though these two outputs are the same, the inputs are different, and that's fine. So this is a function. What would not be a function would be if negative 3 went to 19, and if it also ended up with, let's say, another number like negative 3, or another number 0. This is not a function in that case. Not a function. But our table is a function. Since each input has only one output. Monday night homework number 3, calculate f of 4 for the function f of x is equal to 1 over 5 to the power of x. So remember from last week when we were working with evaluating functions, we knew to plug in this value given in place of the x in the function that's provided. So then we're going to rewrite this f of x, or f of 4, equals, and instead of 1 over 5 to the power of x, it's going to be 1 over 5 to the power of 4. Now what exactly does that mean? So whenever you have an exponent, it's repeated multiplication. So that just means it's going to be 1 over 5, or 1/5, times 1/5, times 1/5, times 1/5. So that's the same thing as 1 over 5, or 1/5 to the 4th power. Then we have to simplify the expression by multiplying all the numerators, which is just 1. And then we multiply our denominators, which is 5 times 5, which is 25. 25 times 5 is 125. And 125 times 5 is 625. And that is the solution. Number 4, we're solving the equation for the indicated variable. This is a linear equation. Remember linear equations? You're pretty much just trying to isolate one of the variables, the variable that they want us to isolate in this case is x, which is located on the top of this fraction. So then we have to remember what types of operations to use to work with this fraction, to work around this fraction. So this 3x or 3 times x, you could also look at it as being divided by 2. So if you want to get the x by itself, you want to get rid of this divide 2 by multiplying by 2. You're going to multiply both sides by 2. When you do that, on the right, the 2's cancel. 3x comes down, and then you have 2 times g on the left-hand side. So then the only thing left to do is to divide. To get the x totally by itself, you'll divide both sides by 3. Those cancel. The 3's on the right. You have x on the right-hand side by itself, and on the left side, 2g over 3. You could also choose to flip that around, reflexive property, 2g over 3. And that's it. Alright, number 5, find the domain and range for this graph. So remember that domain has to do with our x values. So domain, we're looking for our x values in which this graph covers. So as we're walking from left to right, the first value that we come across, walking from left to right on the x-axis, is going to be -4. As you can see, this line goes through -4. So -4. And then if we keep walking across from left to right, we're looking for the very last value that we walk across over this graph. And that looks like it's +2. So our domain includes -4 and 2, and we have closed dots. The closed dot on either end of this function indicates brackets. So there's the domain. And then as for our range, we're looking in the opposite axis, which is the y-axis. So this time we're walking up. We're walking up the y-axis and looking at the values that we see from bottom to top. So then if I draw my line crosses or intersects with what number? Starting at the origin, you can count down -1, -2, -3. So -3 would be the first value of our range. And then if I keep going up, 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 the range ends at this point here, which is at 5. And to figure out if we use brackets or parentheses, again, we look at the circles. This is a closed circle, and this is a closed circle, so then again we're going to use brackets. And there's your domain and range. Closed, which means we have. Number 6, write the inequality in interval notation. So this is review from when we learned about interval and inequality notation, and you have to be able to look at the graph and write the information in interval notation. So then just look at the number that we're provided with which in this case is right here. It's -1. So we know we're working with a -1. Now we have to decide, are the numbers that we're dealing with greater than or less than -1? And what we use to represent the numbers greater than -1 in interval notation. It's different than inequality notation. Okay, so interval notation uses either infinity or -infinity. And we know that this is pointing in the positive infinity direction. So -1, comma, positive infinity. And we also notice that this is an open circle. An open circle means we're going to have parentheses. And around infinity, we're always going to have parentheses. So this is your interval notation. Problem 7 and 8 covers pretty much everything we just learned about today, including where the graph increases, where it decreases, the max point, the min point, the domain range, the y and x intercepts. So let's take a look here. Increase and decrease. This is when we can draw some boundary lines to look at the different intervals of where we're walking downhill, walking uphill, if there are any constants. So starting from the left and working your way across the graph, you can see the first point of this graph shows up there at -7 on the x-axis. And then you continue walking down. It's a downward decrease, basically. And you keep walking down until you get to -4. And then from that point, you're walking uphill until you get to the y-axis, which is 0. And then after that, you're going to keep walking downhill until you get to this point, which is at 2. All right, so there are 4 intervals that have to be identified between increase and decrease. So you're going to have to see here that, I'll just color them differently. This section right here, when we're walking down, all right, so that's a decrease. And again, you're only looking at the x values, so that's -7, to -4. And you notice I'm using brackets because the dots are closed. We also have another decreasing interval right here from 0 to 4. So that's going to be a u, and then 0, 4 with brackets. All right, so those are the decreasing intervals, and then we have one increasing interval that we need to represent here, and that is between -4 and 0. -4, 0, and closed dots, so again, brackets. All right, max point, min point. I'm going to use my highlighter, and I see that the very highest point on this graph crosses here, and the lowest point crosses here. Okay, so for max and min, we're looking at the y values this time, the y values, so you have to see where you are on the graph, and it's hard to see here, but this is the origin, 0, 0, so you can count up 1, 2, 3, 4, and you can even see from this coordinate here. So let me write down, the max point would be 4. We're only worried about the y value. And then the minimum point, you can see down here, you can see that that takes you down to -5 for the minimum. All right, and then we can look at domain and range. So then for the domain, again, with the little person walking across, you kind of have already identified this by looking at the very first interval and the line for the very last interval. That's going to help you figure out the start of the domain and the end of the domain. And again, looking at the x values, so -7, you can see -7 on the x-axis. All the way to the right, you get to 2, positive 2. Closed brackets. And then the range, again, you've already kind of figured that out when you looked at the maximum and the minimum, where the green highlighter is. So the range is from bottom to top. Alright, so bottom to top, you're looking at the bottom value being -5, comma, and the top y value being +4. Excuse me. So then, your x and y intercepts, that's the only thing left to take care of. X and y intercepts. So the y-intercept is where the graph crosses the y-axis. So the y-axis is kind of buried here, but here's the y-axis in yellow. Where does it cross? It crosses right here. And what exactly is that under all that? It looks like it's at 4. And then our x-intercept is where, intercepts, is where the function crosses, or where the graph crosses the x-axis. So in this case, the x-axis is here. We can see that the line crosses at that point and at that point. If we guess, we can make a real kind of loose guess. So one of the intercepts would be -2. I'm sorry, that's not -2, that's negative. Let's see, there's the origin. 1, 2, 3, 4, 5, 6, -6. So one of the x-intercepts is -6, and the other one would be 1, 2, -2.5. And there you have it.